In adding and subtracting fractions with similar denominators, you just simply add their numerators. For example, 2/4 plus 1/4. So, first, you copy the denominator, 4, then add the numerators. 2 plus 1 is equal to 3, so the answer is 3/4. So, in subtracting fractions, we're going to use the same process, except that the operation we're going to use is subtraction. So here, 2/4 minus 1/4. First, copy the denominator, 4. Then, subtract the numerators. 2 minus 1 is equal to 1, so the answer is 1/4.
While in adding and subtracting fractions with different denominators, first, you must get the LCD of the denominator. After getting the LCD, divide it by the denominator, then multiply it by the numerator. Once you're already done, you can now add the numerators. For example, 1/2 plus 1/4. First, you must get the LCD first. So the LCD of this fraction is 4. 4 divided by 2 is equal to 2. Times 1 is equal to 2. Next, 4 divided by 4 is equal to 1. Times 1 is equal to 1. You can now add the both numerators. So, 2 plus 1 is equal to 3. So, the answer is 3/4. While in subtracting the similar fraction, we're going to use the same methods, except the operation we're going to use is subtraction. So, 1/2 minus 1/4, you must get the LCD first. So, the LCD of this is 4. 4 divided by 2 is equal to 2. Times 1 is equal to 2. Next, 4 divided by 4 is equal to 1. Times 1 is equal to 1. So, 2 minus 1 is equal to 1/4. So, the answer is 1/4.
For example, 3/2 times 2/4. So, 3 times 2 is equal to 6 and 2 times 4 is equal to 8. Note that if the fraction is still possible to be reduced, make sure to reduce it to its lowest term. You'll just have to find the GCF of the numerator and the denominator. In this case, the GCF here is 2. Then divide it to the numerator and denominator to get the lowest term. So, 6 divided by 2 is equal to 3, and 8 divided by 2 is equal to 4.
The last fundamental operation on fraction is division. In dividing fractions, first you have to reciprocate the divisor, then multiply the fractions. For example, 1/2 divided by 2/3. So first, we need to reciprocate the divisor, then multiply the fractions. So in here, our divisor is 2/3. So it will become 1/2 multiplied by 3/2. Then multiply the fractions. 1 times 3 is equal to 3. Then 2 times 2 is equal to 4. The final answer is 3/4.
Fundamental operations of decimals. So, in adding and subtracting decimals, all you have to do is line up first the decimal points. Then, you may now proceed. For example,
0.1 plus 2.25. So in here, the first thing you have to do is line up the decimal places. So in here, it will become like this, 0.1 plus 2.25. In adding decimals, make sure that you're going to add those numbers who are in the same decimal places. So in here, just bring down 5, then 1 plus 2 is equal to 3, then point, copy the point, then 0 plus 2 is 2. So the final answer is 2.25. This is the example for subtracting decimals. In subtracting decimals, we're just going to use the same process in adding decimals, except the operation we're going to use is subtraction. So let's line up first the decimal points. 3.35 minus 0.001. So let's add 0 to the end of one number so that they will have the same decimal places. So 0 minus 1 is cannot be, so let's borrow 1 to 5, so this will become 4 and 0 will become 10. 10 minus 1 is equal to 9, 4 minus 0 is equal to 4, 3 minus 0 is equal to 3. Then copy the decimal point and 3 minus 0 is equal to 3. So the final answer is 3.349.
Multiplying decimals, unlike in adding and subtracting, you don't have to line up decimal points. At first, you just have to multiply all the numbers as if they were a whole number. Then, count the total number of decimal places to the right of the decimal points of both number you're multiplying. After counting the decimal places, put the decimal point with the same number of places, starting from the rightmost part of the number, going to the left. For example, 2.2 times 1.3. So the first step is to multiply all numbers as if they were a whole number. So 3 times 2 is equal to 6. 3 times 2 is equal to 6. Next, 1 times 2 is equal to 2. 1 times 2 is equal to 2. Then add. Bring down 6. 6 plus 2 is equal to 8. And bring down 2. Then, count the decimal places. So here, there are 2 decimal places. Put the decimal point in your answer with the same number of places, starting from the right, going to the left. So 1, 2, 2.86 is the final answer.
In dividing decimals, if the divisor is not a whole number, move the decimal point to the right to make it a whole number. And move the decimal point in the dividend the same number of places. Then divide as usual, keep dividing until the answer terminates or repeats. In dividing decimals, if the divisor is not a whole number, move the decimal point to the right to make it a whole number. And move decimal point in dividend the same number of places. Then divide as usual. 144 divided by 20. The answer is 6.
Decimal, divide the numerator by the denominator. For example, 1/4. Divide the numerator by the denominator. So 1 divided by 4 is equal to 0.25. While in converting decimals to fractions, starting to the decimal point, count the decimal places. And if there is only one, put the number over 10 and reduce the fraction to its lowest term. Note that the number of the decimal places will represent the number of zeros in the denominator. For example, 0.5. Starting from the decimal point, count the number of decimal places. Since it has only one, put the number over 10. Then, get the LCD to reduce it to its lowest term. Then, the answer will be 1/2. Just simply move the decimal point 2 places to the right, then attach the percent sign. For example, 0.25. To write decimal to percent, just simply move the decimal point 2 places to the right. Then, attach the percent sign. While in writing percent to decimal, just simply move the decimal point 2 places to the left, then drop the percent sign. For example, 25%. First is drop the percent sign and move the decimal point 2 places to the left. is to change the fraction to its decimal equivalent. Then move the decimal point 2 places to the right and attach the percent sign. For example, 1/4. Since the first step is to change the fraction to its decimal equivalent, the decimal equivalent of 1/4 is 0.25. Then, to change it to percent, move the decimal point, then attach the percent sign. While in writing percent to fraction, the first step is to change the percent to its decimal equivalent by moving 2 places to the left and then drop the percent sign. Then the next thing to do is write the decimal into its fraction. For example, 25%. The first thing to do is to change the percent to its decimal equivalent by dropping the percent sign and moving the decimal point 2 places to the left. Then, next thing to do is convert the decimal to its fraction. 0.25 is equivalent to 1/4.
Percentage are an important part of our daily lives. Percentage is a very handy way of writing fractions. It can be compared more easily than fractions. For example, in malls, shops advertise discounts on products. These discounts are percentage. For example, up to 50% off marked prices. Fractions are also important. For example, in cooking or baking, you need to measure things whenever you follow a recipe. You have half cups, quarters of a teaspoon, and a whole bunch of other measurements. Next is decimal. We see decimal all around us. Decimal break down the whole number into smaller parts. They always have decimal points. You can see decimal prices in store. Receipt also shows decimal prices. So here's an example of problem solving involving decimals. Ellen wants to buy the following items: a DVD player for $49.95, a DVD holder for $19.95, and a personal stereo for $21.95. How much is her change if she has $95? So first, you must line up the given. So, 49 point. Line up the given, then proceed to addition. So the answer is $91.85. Then subtract the total to $95. So the answer is 3.15. Here is the change of Ellen.
Go.
So here's an example of problem solving involving fraction. Sam had 120 teddy bears in his toy store. He sold 2/3 of them at $12 each. How much did he receive?
Go.
Step 1 is to find the number of teddy bears sold. So 2/3 times 120. So multiply the numerator by the numerator and the denominator by the denominator. So 2 times 120 over 3. So 2 times 120 is equal to 240 divided by 3. So the teddy bear sold is equal to 80. Cut.
Go.
So step 2 is to find how much money he received. So 80 is the teddy bear sold, multiply by 12. So the answer is 960. He received $960. So here's an example of problem solving involving percentage. A test has 20 questions. If Peter gets 80% correct, how many questions did Peter miss? So convert 80% into decimals. Then multiply it to 20. So 0.80 times 20. So the answer is 16. Recall that 16 is the number of percentage. It is the answer you get when you take the percent of a number. Since the test has 20 questions and he got 16 correct answers, the numbers of question he missed is 20 minus 16 is equal to 4.
We're going to tackle the difference between ratio and rate. First, what is ratio? In mathematics, a ratio is a relationship between two numbers which indicates how many times the first number contains the second. While a rate is a comparison of measurements of different units like cents and grams. After we differentiate the ratio and rate, now we're going to solve a proportion illustrating real-life situation. Example, Kelvin measured the distance from his door to the park. It is 1.5 miles. The distance from Kelvin's house to the library is twice the distance from Kelvin's door to the park. How far is it from Kelvin's to the library?
There are three types of proportion: the direct, inverse, and partitive proportion. In direct proportion, as one amount increases, another amount increases at the same rate. The formula for direct proportion is y is equal to kx. But first, we must find the constant value. So, y is equal to kx. Substitute the given 9 is equal to k5. Divide both sides by 5. So the constant value is 9/5. Then proceed in finding the value of y when x is equal to 15. So y is equal to kx. Substitute the constant value 9/5. Multiply by 15. So y is equal to 135/5. Divide it. Y is equal to 27. While in inverse proportion, when one value decreases, the other value increases at the same rate. Like in direct proportion, we must first find the constant value. So substitute the y and x by the given. Then perform the cross multiplication. 300 is equal to k. Then find y in terms of x. Y is equal to the constant value 300 divided by 20. So y is equal to 15. In partitive proportion, from the word partitive meaning divided into parts, is a proportion of a quantity being distributed or divided unequally into two or more parts. This is the example for partitive proportion. Divide 1035 in the ratio of 2:3:4. But first, add these numbers, then divide 1035 to the sum of it. So 1035 divided by 9 is equal to 115. Then multiply 115 to 2, 3, 4. So the ratio will be Here's an example of problem solving involving direct proportion. Arthur is typing a paper that is 390 words long. He can type 30 words in a minute. How long will it take for him to type the paper? So 30 words over 1 minute equals to 390 words over x minutes. Perform the cross multiplication. So 30 times x, 30x equals to 390 times 1, 390. Divide both sides by 30. So x is equal to 13. So here's an example of problem solving involving inverse proportion. 20 men can paint a building in 15 days. How many days will it take 30 men to paint the same building? First, divide the means, which is 20 and 15. 20 times 15. Then divide it by 30. 20 times 15 is equal to 300 over 30. And it's equal to 10. Here's an example of problem solving involving partitive proportion. Father will give 1070 to his 3 children in the ratio of 5:3:2. How much will each child get? Divide 1070 to the sum of the ratio 5:3:2. Divided by 10 equals to 107. Then multiply 107 to 5, 3, and 2. 107 times 5, 535. So the ratio is